hello, welcome to Homeschool. This is your class 10 Mathematics NCERT or CBSE board. We are in a 5th chapter, areas related to circles, and this is your exercise 5.3. And this is your last video in this chapter. So we are going to discuss the problem number 13. In figure, a square OABC is inscribed in a quadrant OPBQ. If OA is equal to 20 centimeters, find the area of shaded region. Use pi is equal to 3.14. So observe the figure carefully. OABC is a square. OA is equal to 20 centimeters given. And a square is inscribed in a quadrant. Find the area of the shaded region is the problem. So, how can I find this area of a shaded region? Frame the formula. Area of shaded region. Area of shaded region is equal to area of quadrant. Area of quadrant OPBQ minus area of square. Area of a square OABC. Area of a square is very simple. We know side length. Area of a square formula is side square. So that is 20 into 20. We are going to get 400 centimeters square. Now coming to area of a quadrant. In order to find area of a quadrant, formula is pi r square by 4. Pi value we know 3.14. R. What about radius? Did they give radius? No, we don't know the radius of a quadrant. First, we need to calculate the radius of a quadrant and then we'll find area of a quadrant. How can I calculate radius? How can I calculate? See here, OP is a radius, OQ is a radius, and observe carefully. OB is also a radius of a quadrant. Suppose in a square, I can see here a right triangle. Square, all angles are perpendicular. I know this side is 20 centimeter and this side is also 20 centimeter. Can you find the hypotenuse? Then that hypotenuse is nothing but the radius of a quadrant. So let's start the solution. Given data, if you want, you can write quadrant, square and all. OA is equal to 20 centimeters and all. You can complete that statement. Then directly I am going to continue here. OB is the radius of a quadrant. OB is also a radius of a quadrant. Now, in triangle OAB, by Pythagoras theorem. In triangle OAB, by Pythagoras theorem, what is that? Hypotenuse square is equal to sum of the squares of other two sides. OA square plus AB square. Right? OB, we don't know. OB square is equal to OA. OA is how much? 20 whole square plus AB is also 20 whole square. OB square is equal to 20. 20 so it will be 400 and this one also 20 so 400. 400 plus 400 will be 800. OB square is 800. OB is equal to square root of 800. This can be written as 8 is not a perfect square. So what can we do? Split this. 2 into 400. 400 is a perfect square. Then that will be 20 root 2 centimeters. Therefore, what is the radius of a quadrant OB? OB is equal to 20 root 2 centimeters. OB is also radius, OP is also radius, OQ is also radius. By applying Pythagoras theorem, we found out the radius. Next step, find the area of a quadrant. Area of a quadrant OPBQ is equal to, formula is pi r square by 4. Pi value is 3.14 into radius. What is the radius we got there? 20 root 2 into 20 root 2 into 1 by 4 you can write here, and this point remove and divided by 100. So observe carefully, 1 0 1 0, another 0 another 0, and this will be 2 root 2 into 2 root 2. 314 by 4 into 2 root 2 into 2 root 2. Observe carefully. 2 root 2 into 2 root 2. 2 2s are 4. Root 2 into root 2 will be 2. How? Root 2 into root 2 means root 2 whole square. Square root will be cancelled. So 4 2s are 8. Now cancel with this. 4 2s are 8. And multiply. 4 2s are 8, 2 1s are 2, 3 2s are 6, 28 centimeters square is the area of a quadrant. Next, find area of a square. Area of square OABC is equal to side square. What is the side length? 20 centimeters. 20 square is equal to 400 centimeters square is the area of a square. Finally, area of shaded region is equal to area of quadrant minus area of square. Subtract 628 minus 400. That will be 228 centimeters square is the area of the shaded region. So observe the figure carefully. Where is the shaded region other than the square? So therefore the formula is, in area of a quadrant, subtract area of a square, we are going to get the shaded region area. Is this clear? 14th problem. AB and CD are respectively arcs of two concentric circles of radii 21 cm and 7 cm and center O. If angle AOB is equal to 30 degree, find the area of the shaded region. So observe the figure carefully. So you can see the arcs of two concentric circles. So here this is center O, one circle and another circle, right? This is a sector of two concentric circles. The two circles, other major sector part is not there. Only minor sector part is here, right? For two concentric circles, center O, this is one circle sector and this is big sector for big circle. Now, radius of the two circles, 21 centimeter and 7 centimeters. This circle radius is 7 centimeter and this circle radius is 21 centimeters. If angle AOB angle is 30 degree, then what about COD? COD is also 30 degree. Angle COD is also 30 degree. Find the area of the shaded region. In order to find this shaded region, frame the formula. Area of sector AOB minus area of sector COD. See, if you remove this part, we are going to get the remaining shaded region area. Right? In area of big sector AOB, if you remove area of small sector COD, you are going to get the shaded region area. So let us frame the formula here. Area of a shaded region is equal to area of sector AOB minus area of sector COD. Okay, now Given O is the center of two concentric circles, and these are the two arcs. AB and CD are the arcs of the two concentric circles. Given OC is equal to 7 centimeters and OB is equal to 21 centimeters. First, we are going to find area of big sector. That is area of sector AOB. Area of a sector formula is theta minus sector we are talking here. Theta by 360 degree into pi r square. That is theta angle is also given, right? Angle AOB is equal to 30 degree. If you want, you can write angle COD is also equal to 30 degree, right? Theta value is 30 degree by 360 degree into pi value is 22 by 7. R radius of a big sector 21. 21 into 21. So 0, 0, 3 12s, 3 4s, 3 7s, 7 7 cancel, 2 2s, 2 11s, 11 21s, it will be 231 by 2 centimeter square is the area of big sector. So similarly, we are going to find area of small sector, that is area of a sector COD is equal to same theta by 360 degree into pi r square. That is theta is same 30 degree, 360 degree into 22 by 7, and the radius of small sector is 7. 7 into 7. 7 7 will be cancelled. 0 0 3 12s, 2 6 12, 2 11s, that's it. 11 7s, 77 by 6 centimeter square. Okay, area of a shaded region is equal to area of a sector AOB, that is 231 by 2 minus area of small sector COD 77 by 6. Do LCM 6 and multiply 3 here. 693 minus 77. That will be 13 minus 7. 6, 8 minus 7, 1, 6, 16 by 6. Cancel this, 2 3s, 0, 2 8s. That is 308 by 3 centimeter square is the area of the shaded region. Observe the figure carefully. In area of a big sector, subtract area of the sector, you are going to get the shaded region area. Okay. 15th problem. In figure, ABC is a quadrant of a circle of radius 14 centimeter and a semicircle is drawn with BC as diameter. Find the area of the shaded region. Observe the figure carefully. There is a quadrant and also a semicircle and some region is shaded there. We need to find the area of the shaded region. So identify the quadrant here. BAC and this curve is a quadrant. And on this, from B to C, they have joined and said this is a diameter. With this diameter, there is a semicircle drawn. Now, what is the area of this shaded region? Semicircle completely shaded? No, some part is not shaded and quadrant is completely not shaded. So, how can I calculate that shaded region area? Observe the figure carefully. See, in quadrant, if you remove this triangle area, you are going to get this segment area. Right? Now find the area of a semicircle. In semicircle area, subtract the segment area. We are going to get the shaded region area. So once again I repeat, find the area of a quadrant. In area of a quadrant, subtract triangle, you get this piece area. And again find area of a semicircle. In area of a semicircle, you remove this part area. Then you are going to get the shaded region area. Right? So in order to start your solution, to find area of a quadrant, pi r square by 4, r is known, r is 14 centimeter, pi r square by 4, apply the formula, you are going to get the answer. Then whereas a triangle area, half into base into height, this also you can calculate. Next, coming to area of a semicircle. Area of a semicircle formula is pi r square by 2. But what is the radius of this semicircle? We don't know. First, we need to calculate the radius of a semicircle and then do the remaining calculations. So first, given and all you can write here. Next, I just go with the right triangle BAC. By applying Pythagoras theorem, I can say that hypotenuse square is equal to sum of the squares of other two sides. That is, BC square is equal to AB 14 whole square plus AC 14 whole square. 14 14s are 196. 14 14s are 196. Add these two, it will be 392. That is BC square is equal to 392. Then BC is equal to square root of 392. 392 is not a perfect square. So how can I write this? Let me write this as 196 into 2. 196 is a perfect square of what? 14 root 2 centimeters. 14 root 2 centimeters is what? It is the diameter of a semicircle and hypotenuse of this triangle. So therefore, BC is diameter said. Then radius of semicircle is equal to half of the diameter, that is 2 7s are 7 root 2 centimeters is the radius of a semicircle. Now next, frame the formula here. Area of shaded region is equal to area of semicircle minus, in area of semicircle I need to subtract this. This how we are going to get? In area of a quadrant, if you remove triangle, you are going to get this area. That means minus, put bracket, area of quadrant. Area of quadrant minus area of triangle ABC. Okay. So first, let us start finding area of semicircle. Area of semicircle. Formula is pi r square by 2. Pi value is 22 by 7 into 1 by 2. And radius of a semicircle is how much? 7 root 2 into 7 root 2. So observe carefully, 7 7 cancel and 2 root 2 into root 2 is 2. So 2 root 2s and 1 2 will be cancelled. And here you are left with 7 into 22. That is 154 centimeter square is the area of semicircle. Now next, coming to area of quadrant. Quadrant formula is pi r square by 4. Pi value is 22 by 7 into 1 by 4. Quadrant radius is different. That r is how much? 14. 14 into 14. 7 2s are 2 2s are, and again 2 7s are. 7 into 22 will be 154 centimeter square. Then again, what do you need to calculate? Area of triangle. Area of triangle ABC. Half into base is AC, height AB. Half into base 14, height also 14. 2 7s are 14. 7 14s are 98 centimeter square. Now substitute all these three in this formula. Area of semicircle 154 minus 154 minus 98. Now first subtract in brackets what you have. 154 minus 98 will be 6 and this will be 556. 154 minus 56. 154 minus 56 will be 98. Therefore, your final answer, area of the shaded region, is equal to 98 centimeters square. So, understand the problem carefully. In area of a quadrant, if you remove triangle, this area you will get. In complete area of a semicircle, if you remove this part, you need to get shaded region area. Okay. 16th problem. This is your last problem in this exercise and also in this chapter. So let us discuss this problem. Calculate the area of the designed region in figure common between the two quadrants of circles of radius 8 centimeters each. Observe the figure. We need to find the area of this region, and they have given here two quadrants. Common area, two quadrants, common area is design. Find the area of this design. Observe the figure carefully. We need to find the area of the designed region, and they have said two quadrants, common designed region. You need to find area. Okay, let me mark this as A, B, C, D. Okay. Let me cut this part. Look here carefully. Quadrant. Okay. This is quadrant. And this is the designed piece, what you can see there. Right. So, I have taken only one part. A, D, C. First, I will find this region area. How can I get that region area? In area of a quadrant, subtract area of a triangle, you are going to get half of the design. Right? Then after getting this answer, into 2 you do. Why? Same design region will be there this side also. Or if you want, you can find this quadrant minus this triangle will give you this region. Both you can add, or directly after finding one, half of the design multiply with 2. Right? Let us start the solution. Let us start the solution here and frame the formula. Area of designed region is equal to 2 times I am giving. I have given there 2 times. That means if you find half of this design, if you multiply with 2, you are going to get complete designed area. So 1/2 of the design, how we are going to get? In area of a quadrant, any quadrant you can take, area of a quadrant, subtract area of triangle. Any triangle you can take there, either ADC or ABC. So In order to find this, first let us find area of a quadrant. Given data and all you can write, children. Area of a quadrant is equal to formula pi r square by 4. Pi value is 22 by 7 into 1 by 4 into radius of a quadrant is 8 centimeters. 8 into 8. 4 2s are 8. 22 2s are 44. 44 8s are 8 4s are 32. 35 352 by 7 centimeter square. Next, area of triangle. Any triangle you can take, children, ADC or ABC. I am taking here ADC. Half into base DC into height AD. Half into DC is 8 centimeter, AD is also 8. 2 4s are 8. 8 4s are 32 centimeter square. Right? Now, area of designed region is equal to 2 times area of a quadrant is 352 by 7 minus area of a triangle is 32. Then do LCM here. 352 minus 7 2s are 14, 7 3s are 21 plus 1 22, 224 by 7. That will be 352 minus 224. This will be 8. 4 minus 2 will be 2. 3 minus 2 will be 1. 128 by 7. You cannot cancel here. So 2 multiply for 128. 2 8s are 16. 2 2s are 4. 5. 2. 256 by 7 centimeter square is the final answer. Therefore, what is the area of the designed region? 256 by 7 centimeter square. So, observe the figure carefully. I cannot frame any formula for the complete design. So, what I have done? First, let me find only this part of the area. How can I get this part area? In area of a quadrant, if you remove triangle area, you get half of the design. Into 2 you get this side part. That is only our answer. With this, we are going to end our chapter areas related to circles. And with this part, complete class 10 mathematics is available in our channel. To visit this channel, www.homeschoolchannels.com. NCERT or CBSE board class 10 mathematics, you can see a list of chapters, all 15 chapters, each exercise, every problem is solved in it, and you can go for last year model papers, it might be, or MCQ papers, whatever you need, the content are all available in the channel. So utilize for the best and hope you are going to get a good result. Use all these videos and learn mathematics in an easy manner. So all the best, children. Thank you all.